Okay guys, so a couple things to say before we go into this example. In the last example, I want to bring up some terms, or one term, is parameter, right? So when we look at trying to describe a solution set using variables, we call those variables parameters. For example, in the last one we had those, the solution set was, we would say, was parameterized on W and Z, okay? Yeah, W and Z, right? Because those were the free variables. Now, when we use the word parameter and we use the word free variable, those are not the same thing. They don't mean the same thing. When we say that Z and W were free, they could be free to be any value. And technically they were free because they were not leading variables, right? So remember, a free variable is one that is not a leading variable when the system is in echelon form. Okay, now we could have parameterized the system differently. We could have wrote the second equation, right, in terms of let's say a different variable, and therefore the free variable still would have been the same, but it would have been parameterized on different variables. Okay, so just keep that in mind. Okay, so now let's look at this example here. Okay, so now let's solve this. Okay, so here we're going to eliminate the x's, right? So here I'm going to start by -2 times R1 plus R2. And then I'm going to do -3 times R1 plus R3. Okay, and let's see what we get. So again, we get x plus 2y equals 1. And then this is going to go away. And then what? We get -4y. So we're going to get a -4y here, minus 4y, right? And then this is just going to stay the same. And then of course -2 plus 2 is 0, so that's going to equal 0. And then what do we have here? The next one is going to be, this is going to go away, so -3, right? And then -6 plus 2 is -4, and that's going to be -4y. And then of course this is going to stay the same, minus w, and then of course -2. Let's just make sure I'm doing this right. So -3, -6, -3, and then 4, which is going to be 1, right? So -3, 6, -4, that's going to stay the same. W is not going to change, and then -3 plus 4 is 1. Okay, so there we go. So now we have this resulting system. Okay, and so now what are we going to do? Well, we want to get rid of the y here, right? So the next operation is to take -R2 plus R3. And so the top equation is going to be left unchanged. And the second equation is going to be left unchanged. This is going to go to 0, this is going to go to 0, and this is going to be left unchanged, so -w equals 1, right? Okay, now, so now look at this. We have leading variables. The leading variables are x, y, and w. So that means, and it's in echelon form, which means there are no free variables, which means there's going to be one unique solution. Okay? So, to parameterize right W, oh, actually, hold on a second. No, I'm sorry, Z. I was getting, so Z is not a leading variable. There are 4 variables, right? So Z is not a leading variable. So Z is free. Okay? So now, there are infinitely many solutions, but keep in mind that not all of the variables are dependent on the free variable Z. Look at W. W is not dependent on Z. W is a constant. So we know that W is equal to -1. Okay? And what else do we know? Well, yeah, X and Y are going to be dependent on Z though, right? So Y is going to equal what? 1/4 Z, right? And then X is equal to -2Y plus 1, but that's equal to what? -2 times 1/4 Z plus 1, which then is what? -1/2 Z plus 1. Okay, so now we have it parameterized. Okay? And so the way we would write this solution set is this way. I'm going to start over here. So I have room. So X is going to be 1 minus 1/2 Z. Y is 1/4 Z. Z is just Z. And then W is -1, such that Z is an element of the reals. And that's it. So parameterizing solution sets shows that systems with free variables have infinitely many solutions. Okay, that's it. Have a great day.